Welcome. I hope you've all enjoyed your time at GOSIM. Thank you for coming to my talk. I'm Daniel McNab, an open source maintainer in Linebender, which is an open community working on user interfaces. You can connect with Linebender using the links on screen. This talk is focused on Masonry, which is one Linebender project. My work is currently funded by Google Fonts. Views expressed in this talk are my own. You can find the slides by following the QR code, which will also be shown at the end. Today, I will be talking about the baseline for app quality and how this makes innovation in UI frameworks hard. I will then introduce Masonry, which alleviates some of this difficulty by allowing more parts of UI frameworks to be shared between projects. Afterwards, I will discuss some of the other libraries developed by Linebender and how you can use these in your own projects independently of Masonry. We will then have a few minutes for questions. This talk will be focusing on cross-platform applications, such as document editors or social media apps. Mobile is an important part of the cross-platform experience. My own work is currently largely focused on Android. There is still room for innovation in UI frameworks. We have seen this throughout this track. However, users of an app don't care what UI framework was used. They want to understand how to use the app, which is easier when the app meets their expectations. These expectations set a baseline for how any app must work. Meeting this baseline necessarily involves work by the app developer. However, many parts need support from the framework as well. So to give some exact context of things that this covers, on macOS, applications are expected to expose most features through the menu bar, the bar at the top. This enables platform-provided automation and improves discoverability of features. Input methods, a catch-all term for supporting mobile software keyboards and software input for large character sets such as that of simplified Chinese, also needs to be supported. Focus handling, so keyboard navigation with the tab key, for example. Touch gestures, drag to scroll, pinch to zoom, and similar is especially important for mobile, but is also relevant on desktop platforms. Tabs, so that's where you have multiple documents in the same window. Translations and other internationalization features are also necessary to support. And there are many other requirements, including performance, other similar non-functional requirements, and correct text rendering of all scripts. Accessibility is also a core requirement. A good app must be usable by as many of its potential users as possible. Getting accessibility right requires combining a lot of different features, including connecting to platform accessibility APIs. This enables accessibility tools such as screen readers and voice control. Additionally, some automation tools, especially on Windows, also use the accessibility APIs. Keyboard-only navigation is also important for accessibility, but it also helps power users use the app more efficiently. There are several other accessibility features which must be supported. Additionally, it is or will be a legal requirement that apps meet accessibility guidelines in some jurisdictions, such as those covered by the upcoming European Accessibility Act 2025. Getting all of this right requires a lot of work. Large parts of this work falls on framework developers as they are best placed to integrate solutions. There are existing libraries for some of the sub-problems mentioned. To pick a few examples, Muda, AccessKit, and Fluent address some of the problems as described on the slide. However, integrating this into a toolkit still requires careful work, potentially requiring updates across all parts of a framework. That's especially true for integrating accessibility and internationalization. Additionally, some problems inherently cannot be solved by a generic library, as they make use of widget-like functionality. This is especially true for window menus, which you must implement on Linux and Windows. All of this integration work is being repeated in slightly different ways in each UI toolkit. So consider GTK. It has its own widget behavior and implementation on text input on top of its own platform integration and integration with a 2D drawing library. Same applies for Flutter. If you want to develop a new toolkit for your flagship application, you'll be spending a lot of time implementing all of these features. And if you don't, your app will instead be missing important features such as window menus. For a UI framework to be widely useful, it must allow apps using it to reach the baseline set by user expectations. However, the work this requires is very grungy and isn't what makes your project stand out. This means that the amount of effort which can be spent on developer experience is limited. This in turn leads to a limit on the innovation in UI toolkits. This work has been done in a lot of existing UI toolkits, but it hasn't been designed for reuse by other toolkits. This means if you want to use this work, you have to use the state management model of this toolkit in question. Existing toolkits have a strong interdependence between user experience features and their own wiring. The most commonly used alternative to these application toolkits is the web DOM. In the current landscape, building from a browser technology has a number of advantages. It means you don't have to spend as much time implementing these features. However, it does have a number of limitations. The browser as it stands was largely designed for static documents. Improvements for applications have been added, but there is still a lack of flexibility for advanced use cases. For example, content-rich apps, including Google Docs and Figma, largely disregard the DOM and instead build up from canvas-like primitives. This leads to a poor user experience in a number of cases, such as through unnatural feeling scrolling and poor accessibility. Because of these shortcomings, we have made our own project in Linebender. This brings us to the project which my team works on, which is called Masonry. Here is a selection of screenshots from Masonry's current examples. Masonry is a retained mode user interface library for cross-platform toolkits. It's not in itself a new toolkit, but it's instead designed for higher level projects to use it to create their own toolkit. That is, we do not expect new apps to be developed using Masonry directly. It is instead a core for these higher level toolkits, which apps themselves would select from and use. Linebender develops one higher level toolkit alongside Masonry called Xylem. Masonry currently works on macOS, Windows, desktop Linux, Android, and iOS. Masonry is written in Rust, but could be used to create non-Rust high-level abstractions. Masonry acts as a new layer in the cross-platform stack, implementing features which are common between all UI toolkits. This is reminiscent of the web DOM, and that there are many frameworks such as React or Solid that make use of it. Masonry is designed from scratch to meet the needs of apps, rather than documents as in the web. This gives it the aim of bringing this innovation advantage of the web to cross-platform app development. Masonry abstracts many of the complexities required to reach the baseline set by user expectations. This allows innovative new UI toolkits to be built on top of it. So, for example, we've got Xylem, we've got my own secret project, and then if your shiny new UI toolkit was being created, Masonry would be a way to simplify that, creating that. For toolkits built on top of Masonry, there is also some natural interoperability. This is due to the common vocabulary of widgets. Masonry's API is imperative and retained mode. It intentionally does not provide a high-level API and makes all operations explicit. That is, you create an element and then later access that element and change its properties So, for example, in response to a button press. This means that operations may require a lot of code. Masonry's base API is not designed to be ergonomic. However, this design is ideal for higher level abstractions to be built on top of it. These can then provide the ergonomics that app developers require. The API provided by the web is similar in that you can create an element and set attributes of that element, and then web frameworks build on top of that foundation. Beyond providing features needed by Toolkit, Masonry has some other priorities. The first of these is that it allows you to create robust apps. This is achieved in a few ways. Masonry has a built-in testing API, which easily allows creating tests for toolkits and apps which use Masonry. It also integrates with the excellent tracing crate, which aids debugging. The internal wiring of Masonry has a consistent and understandable design through the so-called path system. In this system, each unit of work which is performed by a widget has well-defined semantics and boundaries, and the required complexity of any individual pass or step is limited. This means that if something goes wrong, it can be easier to understand which code is responsible and resolve the issue. There are also many checks for things not working as expected, which causes a fatal error in debug mode. This helps avoid Masonry from introducing inconsistent states, which limits the potential for jank. In release mode, some of these checks will still run, but won't cause a fatal error, and instead will only raise an error to the tracing system. We have several further planned debugging tools, although the implementations of these are incomplete. We have also designed Masonry to prioritize performance. A few of the techniques used are discussed here. We use a retain mode so that work is only redone when needed. This is achieved by using a set of Boolean flags for whether updates are required. These are read by the path system I mentioned in the previous slide. We also, so we here being Linebender, develop and use a high-performance 2D renderer. This has enabled us to develop some applications using Masonry which prior systems have had performance issues with. The main example that uses this is the example using variable fonts with animated parameters. I will discuss this renderer further in a few minutes. We also have planned for additional performance improvements. So one of those is virtual scrolling, which is a technique whereby the framework requests content from the app as it scrolls into view, which reduces overhead from scrolling. We have experimented with virtual scrolling in the past, but this work is not currently in the main version of Masonry. We also plan to integrate with the system compositor, which will allow further reductions in power usage. We have done recent work to align our internal design with the needs of a compositor, but we have not yet implemented this integration. Masonry's application focus can be seen in the widgets it supports. We have developed a well-behaved text input widget, which can be used in many places in applications. So, for example, the input box of a chat app or a search box. There is also a growing set of other built-in widgets, such as images, spinners, buttons, checkboxes, and sliders. We have several implementations of layout algorithms and also intend to integrate with Taffy, which is a CSS layout library. A key advantage of Masonry over the web is the ability to create custom widgets when needed. This is especially useful for the key unique components of your apps, so if the main part of your app is a graph editor, you would be able to create a custom widget for that section, which can then use child widgets or which use normal Masonry widgets. These would have full access to our high-performance 2D graphics renderer and can fully customize all behavior of the widget and the placement of their child widgets. Masonry makes good use of existing ecosystem crates so that where existing solutions exist, we can share improvements with them. We use AccessKit for our platform accessibility API integration. So every widget in Masonry is exposed to the platform accessibility system as appropriate, enabling screen readers and voice control as discussed earlier. We use Winit, which is the standard Rust project for platform integration. As we make improvements in how Masonry integrates with the platform, we can share these improvements with large parts of the UI ecosystem as we contribute them upstream to Winit. We're currently doing a lot of work on improving Android support in Winit. WGPU provides a shared GPU foundation, which Masonry use. This ensures WGPU ensures memory safety, allowing for improved reliability. It also allows embedding 3D graphics and other GPU work into Masonry products. So, the current status of Masonry is that there are strong foundations in place. This is our high quality rendering and text handling. Masonry is currently used by Xylem, which is Linebender's flagship user interface project. For more information, you can see Rafe's talk from earlier this year. We have some exploratory styling support, but we have been prioritizing getting correct behavior. This does mean that apps using the default widgets are not very photogenic at the moment. This work is in early stages. Masonry is still in a pre-alpha state, but we have recently completed some long-standing changes to prepare us for the future. If you think that the Masonry vision is a vision that you agree with, more contributors are always welcome. If you're interested in starting a new UI toolkit, I'd love to help you build that on top of Masonry. Some underexplored angles would be using signals and slots, for which you might be able to use crates like Leptos Reactive. We have some ideas for how styling can work, but more experimentation in this direction would be welcome. We would also like to add support for additional platforms, especially the web and OpenHarmony. The web has some challenges with accessibility, but that has seen some improvement. We would also like to have more testing on iOS. We know that this is a big task, and we've been solving a lot of problems along the way. We have designed abstractions and libraries for some parts of this, which can be used independently from Masonry. So, I mentioned earlier that we have a 2D graphics renderer. That library is called Velo. It was built for Masonry and with user interfaces in mind, but performs well for other use cases. We have, for example, seen the development of video games and other complex motion graphics apps using Velo. As I mentioned earlier, its performance allows a lot of headroom for advanced graphical effects in apps. More experimentation in this direction would be welcome. We recently released version 0.3.0, which is the first non-experimental release of Velo. You can see Rafe's talk from last year for more details on how Velo works and how to use it. Here are some pictures, or here are some screenshots from projects which use Velo. So on the left is Velis, which is used to render typed documents, which it also has some animation support. In the center, you can see that how Velo can render thousands of dynamic paths at interactive frame rates. This screenshot is of Velo's MMark example, motion mark example. There is also support for Lottie, as can be seen in the screenshot on the right, and SVG through other Linebender projects. Parley is a robust text layout library in Rust. It solves similar problems to Cosmic Text, building on the new Fontations work from Google. It has support for editing as well as more static text layouts. We've recently released version 0.2.0, which has carefully designed text editing primitives. Blitz, which was the library introduced by Nico Burns yesterday, uses both Velo and Parley. So Blitz is a partial web renderer designed for bringing web applications across to cross-platform scenarios. If you want to use these underlying libraries, we at Linebender will be happy to help. We have weekly meetings, which anyone is welcome to join. You can see details in the Office Hours channel on the Zulip. You can contact me directly on the Linebender Zulip. I also have appointments available at a few times weekly, if you wish to discuss this with me one-on-one further. You can find the link to this on my GitHub page, which is shown on screen. And we, of course, accept pull requests and issues on GitHub across our repositories. Thank you for listening. I hope that I can meet some of you at future GOSIM events. This has been my first experience presenting at a conference, so any feedback is welcome. I believe we now should have some time for some questions. If your question isn't asked in the live Q&A, you can contact me on Zulip in the linked thread. Unfortunately, we can only accept questions in English on Zulip. Thank you.